Angles of elevation and angles of depression. It's still 13.1, yeah. Angles of elevation and angles of depression. Angles of elevation and angles of depression are something you guys have worked with last year as well. When you guys worked into the auditorium, we did the lab, the planometers, you guys were working with the angles of elevation.
That was so fun.
Yeah, it's practical use of math, it really is. So you guys were taking an angle of elevation, we'll talk about that one first. An angle of elevation, if you want to think of it, is from your eyesight, there's some horizontal line. Do you agree?
Yeah.
There's some horizontal line that's straight to my eyesight. When I look up from there, this angle off the horizontal is what's called your angle of elevation. Sometimes they put that angle of elevation to an eyesight. Sometimes you say it's an angle of elevation from the floor. It just all depends upon the type of problem.
Or if you look to the left.
Ah!
That's
Put it away.
it's
I'm
another
taking
dimension.
picture of the notes from yesterday so I can have them. And then I'm going to do it on.
The angle of elevation, it's a really simple style problem that you guys have worked with in the past. It's most of you guys, the worst thing you guys have with this is just interpreting some of the words that come from it, knowing what horizontal and vertical mean. The angle of depression is when an object is up above. Let's see if I can do this.
Looking down.
That's so professional.
The angle of depression is thinking of when there's an object up top, also has an imaginary horizontal line, and it's the angle that it's looking down upon. Okay.
That makes a rectangle.
Yes, in theory it makes a rectangle. That is your transversal. What do you know about two parallel lines cut by a transversal?
They're angles.
So basically what happens here is you get alternate interior angles for angles of depression and angles of elevation. They're the same. Okay. The angle of depression is the angle at which you're looking down at a value. So if I'm looking, instead of looking horizontally, if I'm looking at the wheel of that cart, that's my angle of depression. The angle of elevation from the wheel of the cart to my eye would be the angle of elevation. They are the same value, they're just looking in two different spots of the transversal. That's all that is. Elevation, depression, very, very easy style problems. What I want to do here is just kind of go through a couple. I didn't get a chance to run off a bunch of good examples with you guys, so I'm just going to go through and show you guys a couple of quick examples and show you how I draw things out and solve them through. It's simple, simple, easy.
Those, the angle of depression and the angle of elevation are equal.
Yes, sir? Yeah, because remember, there are two parallel lines cut by a transversal and you got alternate interior then. Yeah, yes, these would be,
Yeah.
those two would be parallel. Okay. I know it's boring.
I did.
Let's see, let's do, David is going to the moon. David is going to the moon. To get there, he has to travel at a 70-degree angle of elevation. If the moon was straight above the Earth, it would be 200,000 miles away. In other words, the vertical distance from the Earth to the moon is 200,000 miles. Find the distance that David needs to travel to get to the moon. So David is an astronaut. So David is probably going to take a rocket.
I was going to find some rockets so far. Oh, what about a boat? But here's the airplanes are so cool. There's more color.
Ooh,
Oh, cute.
That is awesome.
That's a great rocket.
And it's already at a degree. It's got stars coming out. So David,
Don't they?
That's how they get in the sky. This is your best drawing yet.
So he's riding, he's standing on the rocket because he's cool like that.
He doesn't need oxygen. No oxygen needed.
No. And he's got to go to the moon.
Not even an astronaut suit.
so David is going to the moon on his rocket.
You're the one with the bat.
Whoa! I knew the moon was big, but I didn't realize it was that big.
That's life size. Yeah.
So,
I love these things. They're just absolutely absurd. So David is he's surfing his way up to the moon. And he lands on the moon.
It was like perfect.
I can't do that more than once. Remember, there's a horizontal distance and a vertical distance.
Vertical is
No, you should draw it down.
The vertical distance is how much?
200,000. No, Mr. Murphy, it said if the moon was straight above you. You did it down here, so you should make it work for the others.
Yeah, you're too much work.
Stop.
There. What is the angle? This is so bad. 70 degrees. So in order for David to go to the moon, yes! How far will David have to travel to get to the moon? He's got to travel the hypotenuse, doesn't he? Okay. So what trig function is going... This is the dumbest drawing I've ever made. And I've done a lot of dumb drawings. Yeah, I have to use sine in this case. I have to find the hypotenuse given my opposite. So we have the sine of 70 is 200,000 over x. And yeah, I heard you say it. When you have the variable in the denominator, you just flip-flop the trig function. Ladies, stop talking. I think we're going to make a new rule. You two can't sit next to each other anymore. It'll probably benefit you both. Okay? So you use your calculator around to a couple of degrees, or a couple of decimal points, and you're good to go. All right? Make sure you're in degree mode, please. We're not in radians yet, so we have to worry about it.
I realized that probably too much.
Yeah, when you start getting weird values or negative numbers
Yeah, I
and
got
stuff.
negative. I was like, wait.
Something ain't right here. Yes, ma'am. What? Radians is when we're talking about the unit circle. Radians are how many degrees are built into a circle. A circle has a distance around of 2 pi. So it's in relationship to pi. Okay. It's so easy to work with. It's so much easier to use. All right, third time the charm. Oh, and he died. Ah! Crashed. That looks like you had bad burrito coming out of the moon. I love these problems. All right, let's see. This one's fun.
Airplane. Yes, there's a building.
This is great. This is so stupid. Go figure,
Are
right?
you gonna animate you make these?
I might. An airplane takes off 200 yards in front of a 60-foot tall building. That sounds like a great place to build a building. So you have an airplane that's taking off in front of a building. The building is 60 feet tall. It's 200 yards away. Now, here's the thing. Notice right off the bat, you've got feet and you have yards. Whenever you have mix-match units, it's generally easier to use the smaller of the two. Because you don't have to worry about decimals and all that kind of junk.
So 600 feet.
Correct. Now, me being a red-blooded American, there's only a certain conversions that I expect you guys to know. Inches in a foot, feet in a yard,
So 60 times 2.
and feet in a mile.
Wait, what's that?
Is it 5,000?
I thought it was
280.
5,280.
I said 50.
So what would you have to multiply that, put that into feet?
3.
So this is 600 feet. So that sounds like not a really good place to put a runway in regards to an airplane. Because when you have an airplane,
He's like smiling. He's so excited.
what did I use last time?
Can we use like a drone?
I don't think they have a drone.
Yeah, like a bomber. But the drones take off.
Take the 732.
We should have a sub. Go with a comet.
I think that this is pretty cool because it's the
Let's go the
biplane.
other
It's
way.
the wrong way. Just use that one that says airport.
He can flip it.
Nice.
Nice. That looks like a Canadian.
Wait, what flag is that? I think it's French.
so what is the angle of elevation that the plane has to take off in order to clear? Oops.
So
Whoa.
it's just.
You want to make sure that you got to find the angle, make sure it clears the building.
Is it
Is it?
Oh, no, because you are.
No, I just got here.
Yes, you want to use tangent in this case. So, because you have an opposite and adjacent,
Wait, what do we know angle?
so the tangent of your angle is 60 over 600. Now, we talked about this last hour. Do you need to simplify that fraction? No. You don't need to do that all. Why bother? Your calculators can do all the work. All right? So in this case here, do you guys remember the sequence of buttons you have to press to find the angle? Tangent -1. That is what we call the arctan. So the angle is going to equal the tangent to the -1. That means theta. You guys are used to calling it x. In altitude, we call it theta for an angle. That's all it is. It's just a letter. And then you just type in your 60 over 600. What do you got, Christian?
So all you did was take tan -1 to both sides, and that canceled that one out.
It's exactly what it is. Because tangent to -1 is what you would. That's how you undo tangent.
How do you do so the angle equals 5.71?
Second tangent.
Oh,
That's
5.1.
So you only have to have an angle of elevation of
5.71.
Oh,
5.71 degrees.
I feel like that's
So it's
not.
It doesn't seem like it's very much, but it's enough to clear the building.
Is it really though?
That's a really small. How far is 600 feet? Like, that's 2.
2 football fields.
Well, not counting kids.
Wait, 2 plus 6?
It's in your arms.
That's not
Did you
bad.
know in the CFL?
Kids are so cool.
Oh,
Yeah, I guess that is kind of far. But like it's a plane. I want to be a plane. If it was like a Boeing, like whatever, that would not work.
I want to be passenger plane.
All right. One other. I want you guys to try to figure this one out.
Is this all we're doing today?
No, we're gonna do some law of science here in a second. A golfer is looking up to the green on a hill. If the tee is 36 yards lower than the green, and the angle of elevation from the tee to the hole is 12 degrees, what is the distance from the tee to the hole?
So the vertical thing is 36.
Green is a color.
The green is where the hole is. The tee box is where you start.
Alright, angle of elevation.
So that's what's, that's the thing, it's there.
What are we supposed to do?
Oh, yeah.
What's that? That's what it says, he's looking up. Well, the ball was in the trajectory, so it's okay that it's going up the hill, he's doing this.
It's about, I told them not to be here tomorrow, Friday.
Yeah, you can do that.
Alright, so if they're gonna do like a test, are we just gonna, just watch the video?
Tomorrow, we're gonna do the ambiguous case of law of signs. Now we're fighting the law of cosines.
Yeah, alright, so.
You've seen law of cosines, you should have done law of cosines last time, I think. That's easy, it's formula work, it's straightforward. The ambiguous case is a little bit weird, I got a little sheet for you, I'll give you today.
Okay, and should I just watch the video?
Yeah.
Uh-huh.
You'll be fine. They're not, it's not tough, I don't give you a lot of these problems to do, so. So, let's look at what this is. You have a golfer who's wearing a hat, because golfers wear hats.
Rounding down.
Yeah, and did you use this class, or did you use this example? That's pretty good.
No, that actually wasn't bad.
That's pretty good.
Went up the hill to the green.
Oh, I don't think I did that wrong. This video. Yeah, Elliot probably did it wrong. Yeah, what if they had a 36?
The hill is
36.
36 yards up.
And your posted is 40 yards.
Yeah, and the person is just.
The angle of elevation is 12 degrees. What distance are you trying to find, the horizontal distance or the hypotenuse? It's trying to find, if you're hitting this, are you going to hit the ball underground?
No.
Yeah, so I thought you're finding the distance.
Right.
Trying to get all this.
So you're going to go, you want to hit the ball and go, whee!
Absolutely different.
So opposite.
So you're trying to find that. So this way you have to find sine. Now in this case here, when your variable's in the denominator, remember the shortcut?
Switch them.
Switch them. So x will equal 36 over the sine of 12. I think what is like 178 and change?
178 or 173.
It's a strong 7 iron. It's a par 3.
That's how we get in six.
So,
Oh, now we're going under.
easy little hole. Okay.
It's like the hole at the mini golf course. Is this when you're done?
Oh, do you know, if you pick up one of the rocks, that's where you can go. Oh, we can go outside. One of the rocks is fake. Well, they're all fake.
Yeah,
You can take the cap off and then reach in and it's there. Yeah.
So let's go to the law of sines. Yeah, we're like I said, we're going to do 13.1 and 13.5 today. Just kind of mix them up, mix them together a little bit. Law of sines allows us to do a couple of things. It's the law of the West. It's Wild West stuff.
I think you put a lot of.
I put too much thought into these.
About that. You're too excited.
Don't. You're gonna make fun of me now.
I was going to ask if I could go wash my hands.
Yes, you can. Walk like you have like boogers or something in it. They won't yell at you. Go, ew, ew, ew!
She has blue stuff in Play again. Play when she enters, so she's.
You guys all remember the law of sines, right? Yeah. Law of sines is how you solve a triangle for their angles and for their sides when it is non-right triangle. There's nothing more than 3 simple ratios. The sine of an angle is to the side opposite it, to each of the 3 angles and corresponding sides within a triangle. Your book does also write it as the reciprocal of it. I will never use it as the reciprocal because it's just kind of pointless, so don't have to worry about that. Basically, remember, it's the sine of an angle is to the side opposite equals the sine of another angle next to its side opposite. And notice that you have 3 ratios. You only need to know one side and one angle, and it matches up to the other ones, and you can solve for everything rather quickly. This is another example of times when you will want to make sure you reuse your givens, because if you screw up on one, you reuse a bad answer, you're going to get another bad answer. What do you mean proofs?
No, like, why there's a word given and proofs, and I think
No. What I mean by this is, as you get into an example like this, okay? What's that? It's right here. It's this right here.
And it's the opposite, like C over sine of C.
Yeah. Okay. Yeah, you don't have to worry about the reciprocal on this. Now, what happens with these things is that the cases that you guys worked with last year,
that we're doing proofs. Stop.
what happens here, just like you guys did last year, is that you guys were given information like this and you just had to solve the triangle. This is nothing different than what you did last year. This is just straight review today. What we're going to do tomorrow is talk about what's called the ambiguous case. It gives you the possibility of having one triangle, 2 triangles, or no triangle given the specific side lengths.
So this is for not right triangle?
Yes, correct. And believe it or not, log signs will work with right triangles. It's just something we don't use.
Well, you don't need to.
Correct. It's tricks quick.
Mister, I wrote the log signs that are for triangles that are wrong. 'Cause they're not right. So a little catchphrase.
Did you forget your glasses?
The log signs.
Oh, so I thought you walked out with them and just left them in.
Okay, well, that was really good. I would have let you use them in PowerPoint.
Power.
How are you gonna
Sorry,
talk?
I forgot you.
You can't talk about PowerPoints.
That's a
You're
problem.
gonna give me the itchies. So when you get a problem like this, the first thing you want to do is just draw your picture. Just get a rough sketch. It does not have to be perfect. We're not Picassos. Picasso.
Oh, I got you. I don't understand.
And we're given that information. Now, whenever I do log sine style problems, or even when we start talking about log cosine stuff later on, probably on Friday, is that I'd like to circle my given information that I can reuse. Here's what I meant by given. If you notice that I have angle B and the side opposite it, I'm going to use this ratio with these those two parts to solve for both side A and side C by reusing that given statement. Okay? So as I go through this, I just start by filling in the blanks. I know that the sine of 28 is 226 as, well, we'll work with side C first, as the sine of 103 is to C. Okay? This is, again, nothing more than fraction equal fraction. So we're going to cross multiply and solve out. Now, I'm going to show you the long way forms of simplifying these out. By the time you do 1 or 2 of these, they're so simple. You're going to find some shortcuts in how to solve your equations rather nicely. Across multiply out, I get 26 sine of 103 is C times the sine of 28. And divide by the sine of 28. Yeah, because remember, the sine of 28 is just some crummy decimal. So my value of C is going to be that. Just use your calculator and put it as a fraction and type it all right in. So we had, alpha y equals editor. 26 sine 103 over sine 28.
Yes.
And there's your side length. 53.96. Remember, go 2 decimal places. Yes, ma'am. Good, everyone help you. So side C was 53.96. Now, remember, use your given, because what happens if you got that wrong?
Well, then you got the other.
And if you reuse this angle, the 103 and the 53.96, to find the next side stuff, you're gonna definitely be wrong. But if you reuse the given, you could get one wrong and the other one right. It does allow you to do that. But here's the big kicker. You have to know how to find the angle here.
You add them off and then subtract them from.
28 plus
Yes. So A is 49. Don't screw that up. So then you just redo it. The sine of 28 is to 26. The sine of 49 is to A. You'll also probably notice that sometimes when you're solving these out, the starting point of the equation looks identical to the one you just did. So just move things around to match it up. So it's going to be 26 sine 49 over sine 28. 41.8? I think that's what we got last time around. Now, obviously, without having answers in front of you to be able to check this, could you at least look at that and say, oh, that looks like it makes sense?
Yeah, because the ratios are like the little angle.
That's what I was looking for. Remember the largest angles, you had the largest side length, smallest angle, smallest, and so on. Remember how those correspondence work? Maybe. If you at least that passes, you might be on the right track. You never know. Okay? Scary? Oh, it's just fun.
Give us a
Could do more work.
I would do one more. Solve the triangle, please.
Is that 105 degrees?
It is. It's capital, so it means it's an angle.
Yeah.
Oh,
Now, in this case, this is a different style in this problem that I gave you here.
yeah, I know.
In this one, you're just given one of the angles. Okay? Now, this problem is forcing you to figure out which angle first. A. So we're going to use our pivot. Sine of 105 is to 11, as the sine of A is to 5.
What? Oh, no, I didn't use my.
Multiply by 5, you get 5 sine 105 over 11 is the sine of A. Now, let's multiply both sides by 5. So when you go to your calculator, 5 sine, what was it, 103?
105.
Hit enter. Divided by 11, hit enter. You have some crummy decimal right now stored equaling, don't round it now, because you're not done yet.
1.490571.
Right now, this equals the sine of angle A. Do you agree? How do you get A by itself now? You inverse it.
Inverse sine of 0.439057.
Hit the answer button. And that's the whole idea. There's your angle, 26.04. Okay. Now, if you're using just that 0.44 when you inverse your sine, you're going to be off.
Really?
Yep. You wind up by, you're off by 600ths. 6 hundredths.
It's gonna cost you.
It's like 6 pennies.
Wait, how does it add up?
It does. All right. So that gives you, what did I say was 2601?
You, 26.04.
Now, you kind of have to use the 180 to find the other angle. So hopefully you do this type of problem correctly so you can find angle C.
Alright, so it's okay to just.
You have to, because you're not given the side length across from C. There are times that you have to use what you just found, but the more that you try not to, the better off you will be. Okay. So then you just subtract from 180 to get angle C, and then just reuse law of science to find the other side. Okay? Not bad? Let me give you some of these to try out for tonight.
Okay, wow, actually, that was quick.
So 13.1 stuff is on page. I'm writing down the correct page number this time.
I like geometry stuff.
This is true.
I gave every second geometry.
I think it's because they're doing the same testing right now.
Yeah, they're doing a little bit of law of science stuff right
And
now.
then like,
But they're not going to do any of the ambiguous case, though.
oh, are you sure?
Let's talk about this talk.
No, that's not nice. Do those two sets of props, please. You'd be pleasantly surprised.
You
It's rather
mean
simple.
page 83?
Oh, jeez.
Can we do work on this? No.
Well, it just so happens that angles of elevation and depression generally are word problems.
I just
But they're
really
easy.
like this so far.
Yes, ma'am. I'll be back multiply by five. Oh, sorry. So you have times 5, so 5 times.
Wow.
All right. Do those two sets of problems. We'll call it a day. We'll go into our ambiguous case, which is all of this fun stuff. It's actually pretty simple. All right.
Does it just look how?
Yeah.